This is the solution to problem 114 from homework 1.4. We're told that a rectangular classroom seats 72 students. If the seats are arranged with 3 more seats in each row, the classroom would have 2 fewer rows. Find the original number of seats in each row. So in order to solve this application problem, I'm going to define my variables and I'm going to use diagrams to help communicate my solution. And these are always good practices to follow. So initially, I'm going to let x equal the number of rows in the original arrangement and y be the number of seats per row in the original arrangement, which leads us to this first diagram here, right? So from this first diagram, we can say that x times y equals 72. That's the total number of seats is the number of rows times the number of seats per row. From this equation, I'm going to solve for y in terms of x because later on I'm going to have a system and I'm going to use substitution. The second piece of information that we're told is if the seats are arranged with 3 more seats in each row, so that would mean we'd have y plus 3 more seats in each row, the classroom would have 2 fewer rows, so the number of rows is going to become x minus 2. So using this second arrangement of seats in the second diagram, we can write another equation. And that equation is going to be the number of rows times the number of seats per row is still going to be 72. So we're going to have now the number of rows is x minus 2 times the number of seats per row is y plus 3 is going to be 72. Okay, so this is the number of rows, and this is the number of seats per row. And that product is going to give us the number of seats. Now, I'd like an equation in one variable, not 2 variables. So what I'm going to do here is I'm going to substitute in for y, the expression 72 over x, which came from the first equation, this equation up here. So let me do that. So our equation is going to be x minus 2 times 72 over x plus 3 is equal to 72. And now we need to solve this equation. So I'm going to FOIL, I'm going to distribute each of these terms. So that's going to give us x times 72 over x is going to be 72. Multiplying the outer terms, it's going to be plus 3x. Multiplying the inner terms, it's going to be minus 144 over x. And multiplying the last 2 terms will be minus 6. 3 times 2, or 3 times negative 2 is equal to 72. And now we will continue to simplify this. I am going to cancel out these 72s or subtract 72 from each side of the equation. So that's going to leave us with 3x minus 144 over x minus 6 equals 0. I'm going to multiply everything by x to get rid of this denominator of x. And that will give us 3x squared minus 144 minus 6x is equal to 0. Remember, we'll have to check for extraneous solutions by chance because we did multiply by a variable. That's something to think about. Now I'm going to put this in standard form. So 3x squared minus 6x minus 144 equals 0. If possible, I could divide both sides of the equation by a common factor. In this case, 3 is a common factor of 3, negative 6, and negative 144. So I'm going to divide both sides of the equation by 3, which will simplify this a bit. So this will give me x squared minus 2x minus 48 equals 0. And if I'm lucky, I can factor this. So I'm looking for 2 numbers that multiply to negative 48, but that add to negative 2. Those numbers are negative 8 and positive 6. So I can factor this equation as x minus 8 times x plus 6 is equal to 0. And now by the zero product property, I can set each one of these factors to be 0. So I'm going to use the zero product property here. And that'll allow us to say x minus 8 equals 0 or x plus 6 equals 0. And then we'll solve these, x equals 8 or x equals -6. And now we have to think about whether these solutions make sense. So remember, x is the number of rows in the original arrangement. That's what we set up here. So we cannot have a negative number of rows. So x equals -6 doesn't make sense. And x equals 6 is the only solution. It's not extraneous, even though we multiplied by x. So the only value that was excluded from the domain originally was 0, so we didn't get 0. So we can make our conclusion here that originally there were 8 rows. So original arrangement had 8 rows, which is our value for x, and we need to figure out how many seats per row. So remember, y is the number of seats per row, and we had y was equal to 72 divided by x. So y is equal to 72 divided by x, which is 72 divided by 8, which is 9. So the original arrangement had 8 rows with 9 seats per row. So 8 times 9 is 72. And the new arrangement, just to make sure that our work makes sense, our new arrangement said that we had 2 fewer rows. So we had 2 fewer rows, so we'll have 6 rows. And when we had 2 fewer rows, we had 3 more seats per row. So 6 rows with 12 seats per row. That product is also going to be 72.